Hello my friend, welcome back to the Sleepy Professor channel. I'm glad to see you again. Tonight, we're going to take a journey together into something wonderfully ordinary, something you've probably seen hundreds of times but never really stopped to think about. We're going to explore in gentle and thorough detail exactly how a receipt is printed. Not rushing, not skipping over anything, but really understanding every subtle moment of this everyday process. So settle in, get comfortable, and let me guide you through this quiet, mechanical dance that happens every single day in stores around the world. Let's start at the very beginning, with the paper roll itself. Imagine a cylinder of tightly wound paper sitting patiently inside the receipt printer. This isn't just any paper, it's thermal paper, specially designed for this exact purpose. The roll is usually white, sometimes with a very slight cream tint, and it's wound so precisely that there are no gaps, no air pockets, just layer upon layer of smooth paper pressed gently against itself. The roll sits on a small spindle inside the printer's housing. Think of it like a tiny spool of thread, but instead of thread, it's a continuous ribbon of paper, usually about 2 or 3 inches wide. The paper is thin, delicate even, but strong enough to handle being pulled through the printer mechanism without tearing. If you were to touch this paper, you'd notice something interesting. One side feels slightly different from the other. The treated side, the side that will receive the printed text, has a special coating. This coating is heat sensitive, containing chemicals that react when exposed to warmth. These chemicals are waiting, dormant, ready to turn dark the moment heat touches them. The roll itself might contain anywhere from 50 feet to several hundred feet of paper, all wound tightly and held in place by the gentle friction of paper against paper. It's a simple design really, elegant in its simplicity. The paper doesn't need to be loaded in any complicated way. You simply drop the roll into its holder, thread the leading edge through a small slot, and the printer takes care of the rest. Inside the printer, there's a small rubber roller that presses against the paper roll. This roller has just enough grip to pull the paper forward when the time comes, but not so much that it tears the delicate thermal paper. The tension is perfectly calibrated, a balance achieved through careful engineering. The paper waits in darkness, coiled and patient, until the moment arrives for it to begin its journey through the machine. Now let's move to that moment when a transaction completes. A cashier presses a button, or a point-of-sale system sends a signal. In that instant, the printer receives its instructions. Data flows into the printer's small computer brain, telling it exactly what needs to be printed. The store name, the date, the time, each item purchased, each price, the subtotal, the tax, the total. The printer doesn't rush. It takes this information and organizes it, line by line, character by character. It knows the spacing, the alignment, where to put the dollar signs and the decimal points. All of this happens in milliseconds, but if we could slow it down, we'd see the printer methodically preparing for its task. The printer's internal components begin to wake up from their idle state. Small circuits activate. The thermal printhead, which has been at room temperature, begins to receive power. This printhead is the heart of the operation, a long thin strip that runs across the width of the paper, containing hundreds of tiny heating elements arranged in a precise line. Let's spend some time understanding how this printhead warms up, because it's truly fascinating. The printhead contains tiny resistive elements, each one smaller than the head of a pin. When electricity flows through these elements, they resist that flow, and that resistance creates heat. It's The same principle as an old incandescent light bulb or an electric stove, just on a much, much smaller scale. Each of these heating elements can be controlled independently. The printer's computer can tell each individual element to heat up or stay cool, and this is how it creates letters and numbers. By selectively heating certain elements while leaving others cool, the printer can create any pattern of dots, and those dots form the characters we recognize. The warming happens quickly, but not instantly. The elements need to reach a specific temperature, usually somewhere around 150 to 200 degrees Celsius, which is 300 to 400 degrees Fahrenheit. That's hot enough to cause the chemical reaction in the thermal paper, but not so hot that it burns or damages the paper. As power flows to the print head, you might hear a very faint humming sound. This is the sound of electronics at work, of capacitors charging, of current flowing through circuits. It's a quiet sound, barely noticeable. In a busy store, but in a silent room, you might just catch it. The printer runs through a brief self-check. It confirms that the paper is loaded properly. It checks that the print head is heating correctly. It verifies that the mechanical components can move freely. All of this happens in less than a second, but it's happening nonetheless, a series of tiny confirmations that everything is ready. Now comes the moment when the paper begins to move. The printer activates its stepper motor, a small but precise motor that can rotate in tiny controlled increments. This motor connects to a rubber roller, and that roller presses gently but firmly against the paper. The roller begins to turn and the paper starts its journey from the roll through the printer mechanism. The movement is steady, measured, not too fast and not too slow. The paper unspools from the roll with a gentle resistance, that slight friction we mentioned earlier, providing just enough tension to keep the paper from bunching or folding. As the paper moves, it passes under the thermal print head. The first line of the receipt is ready to be printed. This might be the store's logo or name. The printer's computer sends signals to specific heating elements in the print head, telling them precisely when to activate. The heated elements touch the moving paper for just a fraction of a second. In that brief contact, the heat triggers the chemical coating on the paper. The coating darkens, turning from white to black in the exact pattern dictated by which heating elements were activated. You can almost imagine those tiny elements reaching out, touching the paper with their warmth, leaving behind dark marks like gentle stamps. Element by element, dot by dot, the first line takes shape. If it's text, you might see the letters forming SUPERMARKET, each letter composed of dozens of tiny dots, arranged in the familiar shapes we've learned to recognize as language. The paper continues moving, smoothly, steadily. The stepper motor maintains its rhythm, advancing the paper exactly the right amount. Too much, and there would be gaps in the text. Too little, and the lines would overlap. But the motor is precise, rotating in tiny steps, each step moving the paper forward by a fraction of a millimeter. After the first line completes, the printer prepares for the second line. The print head cools slightly as the paper advances to the next position. Then, once again, specific heating elements activate, creating the next row of information. This might be the store's address. Again, the heating elements pulse with warmth, touching the paper, leaving their marks. The letters appear: 123 Main Street, each character emerging from the whiteness of the paper like a photograph developing in a darkroom. The process repeats. Another line, the city and zip code. Another line, a horizontal line of dashes or asterisks, separating the header from the transaction details. Each line follows the same pattern. Paper advances, heating elements activate, marks appear, Paper advances again. There's a rhythm to it, almost musical. Advance, print, advance, print. Like a heartbeat, like breathing. The paper flows through the printer with a quiet consistency that's almost meditative to imagine. Now come the items purchased. Each one gets its own line. The printer knows to align the item descriptions on the left and the prices on the right. It creates this alignment by controlling which heating elements fire and when. Milk, whole, 1 gal appears on the left side of the paper. The heating elements in that area activate, creating the letters. Then, on the right side, separated by blank space, 3999 appears. Different heating elements, farther to the right on the print head, create these numbers. Line after line, the items appear. Bread, wheat, and 249. Eggs, dozen, and 329. Each line identical in its formation but unique in its content. The paper keeps moving, never stopping, never hesitating. It's a continuous flow, like a gentle stream. The mechanical sounds blend together. The soft whir of the motor, the almost imperceptible crackle as the thermal coating reacts to heat, the whisper of paper sliding against the guide rails that keep it aligned. Let's pause the printing for a moment and really understand what's happening chemically on that paper. The thermal coating contains leuco dyes, special compounds that are normally colourless. These dyes exist in a particular molecular structure that doesn't absorb visible light, which is why they appear white or clear. Mixed with these leuco dyes is a developer, usually an acid compound. When the paper is at room temperature, these chemicals coexist peacefully, not reacting with each other. But when heat arrives, everything changes. The heat causes the chemicals to become more mobile. The molecules start moving faster, vibrating with increased energy. The developer and the dye come into contact. More frequently, and at these elevated temperatures, they react. The reaction changes the molecular structure of the leuco dye. The new structure absorbs light differently, specifically absorbing most wavelengths of visible light and reflecting very little back. This is what we perceive as black or dark grey. This reaction happens remarkably fast in milliseconds. One moment the paper is white, and the next there's a dark mark. It's permanent too, or at least semi-permanent. The changed molecular structure stays changed unless exposed to additional heat or certain chemicals. This is why old receipts sometimes fade over time, especially if left in hot environments, like a car on a summer day. Back to our printing process. This chemical dance is happening line by line, character by character, as the receipt grows longer. The receipt has printed perhaps a dozen items now. The paper extending from the printer has grown from an inch to several inches. Each line adds to the length, and the receipt begins to curl slightly as it emerges, the natural tendency of paper that has been wound in a roll for so long. Now comes the subtotal line. The printer knows to create some visual separation here, so it might print a line of dashes first. The heating elements activate in a repeating pattern, creating a solid or dashed line across the width of the paper. This gives the eye a place to pause, a visual indicator that we're moving from the list of items to the summary section. Subtotal appears, followed by the sum of all the items. The printer must calculate this, or rather it receives this calculated number from the point of sale system. The heating elements create the dollar sign, then the numbers, aligned perfectly to the right side of the receipt, 2453. Another line advances. Tax appears with its corresponding amount, 197. The precision of the alignment is remarkable when you think about it. The printer knows exactly which heating elements to fire to place. That's 7 in the sense position, at the exact same horizontal position as the 3 from the line above. Then comes the total line, often printed in a slightly different format. Maybe the word total appears in all capitals, or maybe there are asterisks before and after it to draw attention. The heating elements create these special characters, these symbols that mean pay attention, this is the important number. The total amount appears, $26.50. This is what was paid. This is the culmination of the transaction, represented now in dark marks on thermal paper. More lines emerge. The payment method is recorded. Visa ending in 1234 might appear, documenting that this purchase was made with a credit card. The printer creates these characters just like all the others, but they carry different meaning. They're part of a different section of the receipt's narrative. The date and time are printed. 01/1/20, 2026, 14:32, 15. Each digit formed by a specific pattern of heated dots. The colon between the hours, minutes and seconds is just a few dots, vertically aligned. The slashes between the date components are diagonal lines, created by heating elements in a diagonal pattern. A transaction number appears, perhaps a long string of digits and letters. TXN 7829, JK Suhu 99283, LK Dninang. This unique identifier is printed character by character, the print head creating each letter and number with patient precision. The authorization code follows, more numbers, more letters, all of it documentation of this single moment in commerce. The paper continues advancing, the stepper motor maintaining its steady pace, the heating elements firing in their programmed patterns. We're approaching the end of the receipt now. The footer section begins. This might include a return policy, printed in smaller text. The printer can create smaller characters by using fewer heating elements, by creating a more compact pattern of dots. Returns accepted within 30 days with receipt appears, the letters slightly smaller, more compressed, but still perfectly readable. The printer knows to change its dot patterns for this smaller font size. Then comes the thank you message, perhaps. Thank you for shopping with us. The letters might be slightly larger again, a friendly gesture in printed form. The exclamation point is created by a vertical line of dots with a single dot below it, separated by a gap. Such a simple character, but it conveys enthusiasm, warmth. A customer service phone number might be printed. Questions? Call 1-800-555-123. Each digit in the phone number is formed precisely, the dashes between the sections of the number created by short horizontal lines of heated dots. Maybe there's a promotional message. Join our rewards program and save. More characters, more heating elements activating, more paper advancing. Some receipts include a survey invitation. Visit www.surveysite.com/345 and tell us about your experience. The printer creates the letters of the web address, the slashes, the numbers. It's all the same process, just different patterns of heat applied to paper. The receipt is nearly complete now. The printer might add some blank lines, giving space between the informational content and the edge where the paper will be cut. These blank lines are created simply by advancing the paper without activating any heating elements. The paper moves, but no marks are made. It's the absence of printing, but it's still part of the process. Sometimes there's a barcode or QR code at the bottom of the receipt. These are fascinating because they're patterns of lines or squares that encode information. The printer creates these just like it creates text, by selectively heating elements to create dark marks against white space. A barcode is a series of vertical lines of varying widths, with spaces between them. The printer creates each line by heating a column of elements as the paper moves past. A narrow line might be created by heating elements for a shorter time as the paper advances. A wider line is created by heating the same elements for a longer duration. A QR code is a two-dimensional pattern of squares. The printer creates this row by row, just like text, but instead of character shapes, it's creating a precise grid of black and white squares. Each row of the QR code is a pattern of dots, and as the paper advances, row after row appears until the complete square code is formed. The printing is complete. All the information has been transferred from electronic data to physical marks on paper, but the receipt is still connected to the paper roll. This is where the cutting mechanism comes into play. Most receipt printers have an automatic cutter built in. This is a small blade, usually positioned just after the point where the paper exits the printer. The blade might be straight, or it might be serrated, designed to cut through the thin thermal paper cleanly. The printer advances the paper a bit further, feeding it past the print head, past the exit rollers, until the printed portion is positioned at the cutter. Then the cutter activates. This might be a mechanical arm that pushes the blade across the width of the paper, or it might be a rotary blade that spins against the paper. There's often a brief mechanical sound, a quick snipping noise, barely louder than a whisper. The blade presses through the paper, severing the connection between the printed receipt and the roll that remains inside the printer. Some printers use a tear bar instead of a blade. This is a serrated metal edge, and the paper is designed to tear along the perforations when pulled against this edge. The cashier might tear the receipt manually, pulling it gently downward against the serrated bar. The paper resists for just a moment, then gives way, tearing along a straight line. The receipt is now free, a separate entity. It curls slightly, remembering its time wound on the roll. The cashier takes it, and in that moment, all the processes we've explored come to fruition. The warming of the heating elements, the chemical reaction in the thermal coating, the precise advancement of the paper, the formation of each character and line, all of it has led to this, a physical record of a transaction. The receipt contains everything it needs to contain. The store information at the top, identifying where this transaction took place. The date and time anchoring it in a specific moment. The list of items documenting what was purchased. The prices showing the cost of each item. The subtotal, tax and total, breaking down the financial components. The payment information, recording how the transaction was completed. The footer information, providing additional details and customer service options. All of this information, which existed moments ago only as data in a computer, now exists as dark marks on a small piece of paper. It's a transformation from the digital to the physical, from the abstract to the tangible. The receipt can now serve its purposes. It's proof of purchase if a return is needed. It's documentation for budgeting or expense tracking. It's a record for warranty purposes. It might even become a bookmark or a piece of scrap paper for jotting down a quick note. Back inside the printer, the paper roll has slightly less paper than it did before. The outer layer has been used, and now a fresh section of paper is positioned at the front, ready for the next transaction. The roll waits patiently on its spindle, coiled and ready. The print head has cooled back down to room temperature. The heating elements are no longer receiving power. They sit in darkness, ready to warm up again when called upon. The stepper motor is idle, no longer rotating. The mechanical components are still, resting until the next signal arrives. The printer's computer has cleared the data from this transaction from its active memory. It's ready to receive new data, new instructions for the next receipt. The cutter blade is returned to its starting position, ready to make its next cut. Everything is reset, returned to a state of readiness and waiting. This process happens countless times every day. In grocery stores, in restaurants, in gas stations, in retail shops of every kind. Millions of receipts are printed daily, each one following this same gentle, methodical process. There's something beautiful about that repetition, about a process so reliable and consistent that we rarely think about it. The paper rolls are replaced when they run out. The printers are maintained and occasionally repaired. But day after day, year after year, they continue their quiet work. Each receipt is both unique and identical. Unique in its specific data, the particular items and amounts and dates it records. Identical in how it came to be, the physical process that transformed blank paper into a documented record. The technology has been refined over decades. Early receipt printers used impact printing similar to typewriters, striking an inked ribbon against paper. Then came dot matrix printers, which use pins to strike the ribbon in patterns. Thermal printing, which we've explored tonight, became popular because it's fast, quiet, and requires no ink or ribbons, just paper and heat. The simplicity is elegant, no ink cartridges to replace, no ribbons to wind, just a roll of special paper and precisely controlled heat. It's efficient and reliable, which is why it has become the standard for receipt printing. After its initial purpose is served, the receipt might have quite a journey ahead. Some people keep their receipts organized in folders or envelopes, creating archives of their purchases. These receipts can last for years if kept in cool, dark places, the thermal coating remaining stable. Other receipts are discarded immediately, tossed into waste bins. They might end up in landfills where they'll eventually break down over time. Thermal paper is not usually recyclable in standard paper recycling streams because of the coating chemicals, which is something that environmental scientists and paper manufacturers continue to work on improving. Some receipts end up crumpled in pockets or purses, subjected to warmth and friction, which can cause the printing to fade. The heat sensitivity that allowed the printing to occur in the first place also makes the receipts vulnerable to additional heat. A receipt left on a car dashboard in summer might become completely blank as the heat reverses or further alters the chemical reaction that created the print. Digital receipts are becoming more common, sent via email or stored in apps, reducing the need for paper. But thermal printed receipts remain ubiquitous, a tangible link between consumers and their purchases. As we come to the end of our exploration, I hope you've gained a new appreciation for this everyday object and process. A receipt is so common that we often don't give it a second thought, but within it is a fascinating interplay of chemistry, mechanics, and electronics. The paper roll, waiting coiled in the printer, the heating elements, warming and cooling with precise timing, the chemical coating, reacting to heat and darkening to form characters and images, the stepper motor, advancing the paper with mechanical precision, the cutter, separating the finished receipt from the continuous roll. Each component plays its role perfectly, working together in a choreographed sequence that takes just seconds but involves numerous precise steps. It's a small marvel of engineering and chemistry, hidden in plain sight in every store we visit. Tonight, as you drift off to sleep, perhaps you'll dream of paper rolling gently forward, of tiny heating elements warming and cooling, of dark marks appearing on white surfaces, of receipts emerging one after another in an endless, peaceful rhythm. The steady, reliable process continues somewhere right now in stores that are still open, serving customers, documenting transactions, printing receipts. The printer doesn't hurry, it doesn't worry, it simply does its work, line by line, receipt by receipt, each one exactly as it should be. Thank you for joining me on this journey into the quiet world of receipt printing. May your sleep be as smooth and steady as the paper rolling through the printer, as warm and gentle as the heating elements doing their work, as peaceful as a completed receipt resting in calm hands. Good night, my friend. Sleep well.